Hey, welcome! Today we are diving into one of the coolest ideas out there, how we can take a bunch of plain old numbers and turn them into visual stories. Pictures that our brains can just get in an instant. It's all about going from points to patterns. Let's get into it. So think about this for a second. How does a map work? It uses a grid, right? Some kind of system to give every single spot on Earth a totally unique address. Well, what if we could do the exact same thing, but for numbers? What would that kind of universal map look like, and what could it possibly show us? All right, so any good map needs a solid framework, a grid. We're going to build one from scratch. And this tool we're building, it's going to let us see relationships that you would totally miss if you were just staring at a list of numbers. And here it is, the coordinate plane. It looks complicated, but it's really just two number lines that cross each other. The one that goes side to side, that's the x-axis. Think of it as your left and right instructions. The one that goes up and down is the y-axis, your up and down instructions. And that super important spot right in the middle where they meet, that's our starting point. We call it the origin, and its address is always 0, 0. Okay, so how do we find our way around this map? We use something called an ordered pair. It's basically an address, and it always looks like this, x, y. The first number, x, tells you how far to move right or left. The second number, y, tells you how far to move up or down. That's it. It's a two-step set of directions to any point you can imagine. Now, this is maybe the most important rule of the whole system. The word ordered in ordered pair is everything. It's not just two numbers thrown together. The sequence is the whole point. Let's see it in action. If I give you the address 1, 2, your instructions are clear. Start at the center, go right 1 unit, and then go up 2 units. Simple. But what if we flip it to 2, 1? Now the instructions are go right 2 units and then go up 1. You end up in a completely different spot. So yeah, order matters a lot. Great. We know how to find any address on our number map. Now let's get to know the layout of the land. You see, this grid naturally splits the map into 4 distinct neighborhoods, or zones. We call these zones quadrants, and they have a specific naming convention. We start in the top right corner with quadrant I, and then we move counterclockwise. So it goes quadrant 2 on the top left, quadrant 3 on the bottom left, and finally quadrant 4 on the bottom right. And here's the cool part. You can tell which quadrant a point is in just by looking at the signs, whether the numbers are positive or negative. In quadrant 1, you've gone right and up, so both x and y are positive. In quadrant 2, you've gone left and up, so x is negative, but y is positive. Down in 3, you're left and down, so both are negative. And over in 4, you're right and down, so x is positive and y is negative. It's a perfect system! But there is one little catch. What if a point is sitting right on one of the axes? Well, in that case, it doesn't belong to any quadrant. It's kind of like standing on the border between two countries. You're not really in either one. So we've been putting single dots on our map. That's cool. But the real magic, the part where this all comes to life, is when we start connecting those dots. This is where we go from static points to dynamic stories. And that's really all a graph is. It's a picture of a relationship. When you plot all the points that connect two changing things, two variables, you get a shape. And that shape, whether it's a line or a curve, tells a story. For instance, look at this. This graph could be telling the story of a car's journey. You don't even need the numbers. You can see right here, where the line is sloping up, the car is speeding up. Then, when the line goes flat, its speed isn't changing. It's at a constant speed. And then, when the line starts sloping down, well, the car is slowing down. The story is right there in the shape of the line. Now, some of these stories show up over and over again in nature, in science, in economics, everywhere. They're so common that their graphs have very predictable, recognizable shapes. Let's look at 2 of the absolute biggest ones you'll ever see. We call these relationships direct proportion and inverse proportion. Direct proportion is simple. As one thing goes up, the other thing goes up right along with it. Think about it. The more hours you work, the more money you earn. They move together. Inverse proportion is the opposite. As one thing goes up, the other goes down. The faster you drive, the less time it takes to get there. See the difference? Let's dig into direct proportion. This is that lockstep relationship. If you double x, y doubles. If you triple x, y triples. It's that predictable. And the graph it makes, it's always, always a perfectly straight line that goes right through the origin. That's its visual signature. Check out the numbers for an equation like y equals 2x. It's so clear. When x is 1, y is 2. When we double x to 2, what happens to y? Bam, it doubles to 4. When we go from 2 to 4, y goes from 4 to 8. See that perfect constant relationship? That's what gives us that straight line. Okay, now for the other side of the coin, inverse proportion. This is the seesaw relationship. If you double x, y gets cut in half. If you triple x, y shrinks to 1/3 of what it was. And its graph isn't a straight line at all. It's this beautiful sweeping curve that gets closer and closer to the axes. But, and this is the cool part, it never actually touches them. Take a look at the data for something like y equals 12 divided by x. When x is 1, y is 12. Double x to 2, and y gets cut in half, down to 6. Jump x up to 4, and y drops down to 3. And here's the hidden rule. If you multiply x and y together in any of these pairs, you always get 12. That constant product is the secret signature of an inverse relationship. So, let's take a breath. We've built a map for numbers, we've figured out how to plot addresses on it, and we've even started to recognize the shapes of common stories. But why does any of this actually matter? What's the big takeaway here? It's because graphs are a kind of translator. They speak a language our brains are naturally good at understanding, the language of patterns and shapes. They take a spreadsheet full of abstract numbers that might not mean much, and they turn it into a clear, simple story that you can understand in a single glance. It's about turning data into actual insight. And that kind of leaves us with one final thought to chew on. Think about your own world. The number of hours you sleep versus how you feel the next day. The amount of coffee you drink versus your productivity. What hidden relationships, what untold stories are just sitting there waiting for you to draw a map and reveal them?